Hello, this section is entitled Networking, Know How to Configure and Use the Cluster DNS. We've already seen some of this already, so some of this is a recap, but just trying to pull together everything we've seen with DNS related to the cluster so far and a little bit more. So first thing is Kubernetes originally launched with a service or a feature called kubedns, and then it's been superseded by core DNS. And essentially, we can see that there are AWS clusters actually using core DNS. So if we run the command kubectl get all with all namespaces, let's see what we see. And if you recall, there is a service. Well, let's see, look here carefully. There, you see this core DNS floating around up here. So there's a deployment called core DNS that, of course, then has its own. Where is? Damn it! Anyway, I was looking for the replica set, but I'm not seeing it. Oh, maybe because it scrolled off the screen. Oh, hang on. There's a replica set. Okay, so yeah, right. So we have a deployment, which then has a replica set, right? It's running 2 pods of core DNS, and then we have a service that's called kubedns, probably for historical reasons. But if you look at it, it's basically it's front-ending these 2 core DNS pods. So this cluster is indeed running core DNS. So right, and then basically you see the address here. This is basically the DNS server for a cluster, 10.100.0.10. Okay, so that's what's doing all of our DNS resolution. Now, I'm trying to think. Oh, right. So I'm going to look at one other thing real quick. So there is a configuration for core DNS if you want to modify its functionality. And there's documentation here on how to do that on the Kubernetes website, right? Customizing DNS service. What customizing amounts to is editing a config map, which is basically a key value pair. So let's look at that real quick. We're not going to spend much time on this other than just recognize that that's not what I wanted to paste. I wanted to paste describe the config map. So I'm describing the config map named core DNS in the kube system namespace. And you can see there's a number of configuration values here. Okay, so I'll leave it at that. Okay, so now I will look at one thing though. There are 2 commonly mentioned, we're not going to demo either one of them, but configurations. One is if you have a subdomain that maybe it's an internal domain that you have your custom DNS servers for some other services outside of your cluster, you can specify it's called stub domains. So there's a configuration there in their documentation about setting up DNS servers based on a particular subdomain, like it's whatever, it's foo.com, and then you want to have a different set of domain servers for that domain. That's one feature. You can also manage the upstream name servers. By default, the behavior is the name servers that get used when the cluster does, it tries the cluster, nothing's in the cluster matches, and then the default behavior is to use the same domain name servers that the nodes themselves use. By using the upstream name servers, you can modify that behavior, which name servers are being used upstream. Okay, so we're not going to change those, but just know that they exist. Okay, now one thing we will look at is, let's look at this. I want to look at this thing called a search list, and I think I'll just do it by example. So let me install this real quick. I guess we should look at it as we go, I guess. So let me there's a folder here called DNS, And in here, I have a bunch of examples. Now, the first example is just a regular pod. So this is just our Ubuntu pod. So we're just going to use it first. So I'm going to deploy the whole thing, and then we're going to talk about this slowly. So let me do helm install dev DNS. Let that install. Okay, so I'll do kube control. Now, actually, I think I have a lot of stuff here because we'll talk about the different examples. So right now, I'm just going to log into the example dev. So if I do kubectl exec example dev and then bash. Let me just make sure I see apt get update. I'm just going to install the DNS utilities so we can troubleshoot DNS. So apt get install DNS utils. Okay. Okay, so I'm ready to troubleshoot. Okay, so the first thing is you'll notice is that there's a file called etc.resolve.com. So I'm going to cat this. Okay, so this basically, this file on Linux or Unix is used to define the host's mechanisms for using DNS. And you can see the name servers indeed are cluster name server, right? And this line is the one I'm paying attention to, this search. So by default, and this is something the cluster actually manages in your pods, in your containers in your pods, it manages this resolve.conf, and it supplies this name server, but it also is supplying this search entry. And what this does is allows you to use shorter names for DNS. So instead of having to do the full, the cluster DNS name, which would be like, for a service, it would be service name dot default, which would be the namespace, SVC cluster local. You could just give the service name, for example, or you can give the service name and the name zone. That's because there's the searches here. You can see that the first search is that because this pod is in the default whatever this thing is, it's in the default namespace. I'm sorry. So then you get this as your first entry, but you also have it without the default. So you can look at, by using the second entry, you can use service name dot namespace to refer to something in the second namespace, right? Or of course you can just use the full name too. Okay, so that's what the purpose of the resolve.conf, and just recognize that this is actually being managed by the cluster to make your instead of having these long DNS names. Okay, that's one topic I wanted to cover. Okay, so let's look at some other things. In this example, I had created a service. So you see this head service. So I have a head deployment, which is just Apache web server running 3 copies, and then the service, head service, is just our regular service like we saw earlier on port 80, right? So the point here is we saw this earlier. There's a DNS name for here, so let's try it out. So if I do ns lookup example, no, this is not example anymore. This service is called, I believe it's called head, head dot dash dev, and you can see the full name is head dash dev dot default svc cluster local, but I can use just head.dev. I could also use head.dev dot default, because those are both in that search list. Of course, I could do the whole thing, which would be svc cluster local. Okay, so that's just one example of, one was using the resolve.conf, right? And two, just recognizing that one of the things that DNS does for us is allows us to find regular, internal IP addresses for particular services based on their name, just like this. Okay. Next example that we saw, right? Let's look back. There's another example of using DNS was by using a headless service, right? Oh, okay. So I'm going to do one other thing here. Okay, before I go into the stateful set, let's look at this headless dev right here. So let me look at the code for that real quick. I'm going to pause the video for a second, make sure I'm oriented. Okay, so we're back. Yeah. So I was just, So this is this headless here. So I have a stateful set, just like we had before, where I was using a stateful set, which is somewhere here, stateful set, right? And then I tied it to a service, which is probably this line right here, right? And then this is just copies of the same HTTPD. And the point of this stateful set is that we actually, instead of getting a single IP, right, we actually have different pods that are named a certain way, and they all get their own DNS name. And then the service backing that was this headless service. Again, the main differentiator here was this cluster IP of none. Okay, so by doing a headless service, and in the case this is a stateful set, a couple things were true. So one was if I do NS lookup on NS lookup, oh my goodness, headless-dev, what you get is you get back A records for each of the pods, but that's less important than doing, you really wanted to do was, you wanted to actually do the pod names, which were, well, I have it in my example here. Here, I'll paste it and we'll look at it carefully. So paste. So in this case, I got headless-dev-0. This is how the pod gets named based on the service, and the service name is still headless.dev, and of course I didn't spell NS lookup right. NS lookup. So I actually got the IP address for the first instance in that headless service, and of course then I can do the same thing with 1 and 2. There's 1 and there's 2. Okay, so that was another way of using DNS with a headless service with a stateful set. We now get basically the service now provides these DNS names for each of the pods. Okay. So there's another example here. Let's say, okay, this is the pod one. Okay, so this example here is, let's look at it here. Okay, so in this case, I create two pods, pod A and pod B, and then I have a service that basically is a again, it's one of these stateless services, right? So if you look at this is a stateless service. It's looking for any basically pod with a selector of pod and the release name. And what it's doing, it's basically doing, this is going to be doing DNS for the pods. And you can see pod A is a pod here, right? I set the labels up so that the service will match it. And there's a couple key things here. You need to provide, when you do it this way, if you're not using a stateful set and you want to tie this pod back to that service, you actually have to provide a host name specifically. In this case, they're called a pod A. And the subdomain has to match the name of the service. So it's an interesting pattern here. But this is how I can create pod A and pod B, and I can get DNS names for them individually because the headless service will provide it. So let me just, by doing this, let me just show you what the final result is. If I do NS lookup, well, I'm going to copy and paste it, and we're going to compare. So if I say paste, NS lookup, pod A was the host name, pod dev was the subdomain, which happens to be the same name as the service that's out there, right? And if I do that, apparently I got to type in DNS lookup. I actually get an IP address for that individual pod. So, of course, the pods are ephemeral, so this is not probably a common pattern. So you can also then look up pod B too, and you get an IP address for pod B this way. So that's just another example of how you can use services to get A records. Now, there's also these service records that basically, and again, I don't. Well, let me just paste it in and we'll look at it. I'm not quite sure exactly how I'd use this, but let me show you what's doing. Paste. Okay, so this is doing DNS lookup of type service, so that's a different kind of record. And the name here is, so let me look at the service here. This is the head service. This is back to the first example. So if I look at the head service, you notice that I've got a named port here. So I've named the port, not just saying that what protocol it is and what port, but I've got a name. And you notice I happen to name it HTTP. I can name it whatever I want it to, right? So what this does is that by doing a query like this, where I use the name of the port, then I tell it what kind of port, this is TCP. I give the name of the service, and now the rest of the name, right? What do we get back? We get back one of these service records. Now, to be honest, I'm not sure what the 0 and 100 are, but this basically tells me, principally, what I'm paying attention to is it's telling me that this service named HTTP, right, runs on port 80 on this name. So it's a way to map a service back to a host, or basically an A record, and a port in which you can get the service. So it's kind of inverting things, where you're finding things by service as opposed to finding the host itself and then just knowing what the port is. So more information. Okay, so there's one other section to talk about. So earlier we talked about how to configure the core DNS feature and how to do that using that config map. Separately, you can configure DNS at the pod level. There's two main things. One is called the DNS policy, which kind of basically describes where the DNS records are coming from. And the default is called cluster first, which means it's going to first inquire the cluster DNS name to see, to get the, look for IP addresses for the cluster. And failing that, it's going to then go out to the external upstream name servers to figure it out. So if I'm looking for Google, it's not going to be in my cluster DNS server. It's going to say, oh, I need to go out to Google's name server to get the name for google.com. So that's the default. There are other settings, but I'm not going to really cover them. I think one in particular is called none, which basically just completely ignores the clusters DNS. It just goes upstream. Again, I'm not fully sure what all the use cases for all that is, but the default is cluster first, is how we've been behaving so far. Now, there is another setting. Now that we've talked about the policy, there's another thing called the config, which is separate. I mean, it's somewhat related, but it's not the same. Basically, it is more detailed configuration for the core DNS as it relates to that pod. And one is you can supply a list of name servers that will be used for that pod, right? As opposed to the ones, basically it's used in addition. So instead of just getting the one, you can have additional IP addresses of other DNS servers. Searches, again, it will add to the search list. So instead of just having the cluster and the one with the name zone, you can add other searches. And then options, if you knew how to configure the etc. resolve file, there's also an options level, options value. We'll look at it again. You can configure that, the resolve.conf there for the pod using this options. So let's look at the code in particular. So there's a new folder called config. Now what I should do is I should turn off, let me get out of this, Helm, uninstall dev. I'll take a minute to get rid of all that. So in config, I have a template, and here I just have a single pod, right? And I've done this DNS config here. So in this case, I've provided google.com as additional search entry. What that'll mean is, if I got this right, when I log into this this pod, the container for this pod, I can actually do a NS lookup just on like Gmail with nothing else after it, and this would append to google.com to it as part of its search list. So let's just give it a whirl and see what happens here. So let's see, kubectl get all. Hopefully everything's terminated. Okay, nice and clean. So I do helm install dev config. Okay. Okay, and then I do kubectl get all. I think I only have a pod right now running, so if I do kubectl exec example dev bash, I think this is right. And of course I want DNS tools, so I have to do apt get update, and then apt get install curl. Okay, let that install. I forget what we're trying to do here. Oh, right. I want to look at that resolve.conf first. So if I do cat etc. resolve. Okay, you will notice that now I've got a google.com as part of my search. That's because I added that DNS config. And by the way, the options thing is this value here. And again, I'd have to research what all the options are here, but you can manipulate that resolve.conf as part of that same DNS config, right? So now if I just do, to test this, I could do NS lookup on Gmail. And what did I just do? Oh, I didn't mean to install curl. I want to install DNS utils. Now I can do NS lookup on, and then I get Gmail. Okay, I believe that is it for this section. So just as a recap again, what did we talk about? We talked about just generally about how to tell which kind of flavor DNS your cluster has. It's either going to be the older kubedns or the new core DNS. We observed that there's a config map that you can use to configure the core DNS kind of like cluster wide, right? And then we talked about, particularly there was a couple options in that. Then we talked about how basically Kubernetes manages the resolve.conf on the containers so that you get a search list where you can basically search, kind of a shortcut search based on just the name of a service or a name and a namespace. And then we talked about the various types of records that are auto-generated by the cluster. We talked about A records in the case of a regular head-based service. And then we talked about a headless example, which was basically drawing from our stateful set example. And then I think that was that. Then we talked about, what was this? Oh, how you could actually use there's two different ways of using the stateless service, headless service. One was through a stateful set, and one was assigning pods directly to the service, right? We looked at these service records, Then we looked at that was it. And then we switched gears, and there was ways to configure a DNS policy and DNS config at the pod level, and we just did a simple example of changing the search list. Okay, that's it. Thank you.